graph and solve linear systems. That means two lines together in some way. And we need to determine if the following points are solutions to. Now notice it says points because one is hiding underneath this lovely yellow box. Now, how do I figure out if 1, 4 is a solution to both of these equations? Good. Now, let's say I plug it into the first one, like I'm doing. I plugged it in, and this actually shows that I knew where x went, I knew where y went, right? At this point, can you guys do 1 minus 12 in your head? I'm okay with that. I believe you can do that, which is, is that true?
No.
Guess what then? I don't have to check the other one. It either has to work for both, or the answer is no, it's not a solution. Because I'm checking that it works for the first one and the second one. Does that make sense?
Now, what happens if it works for the first one?
Then we would still say no. Has to work for both. Okay? Now, like your homework answers, I already gave you the answers, yes and no. They're already there. So you have to show work. This right here is your work, and that's your answer. If you don't want to show 3 times 4 is 12 and write 1 minus 12, I'm okay with that. I can assume you can do that part in your head. Does that make sense? But show me that first step, that way I know you know where x goes and you know where y goes. All right, let's try another one. One more of these. Negative 5, 0. So I'm going to go ahead and show the work. Negative 5. Oops. Negative 5 minus 3 times 0 equals negative 5. Can you guys see this part in your head? I'm okay with that. Does that one work?
Yes.
Okay. That was meant to be a check mark. You're good. Let me try the bottom one then. Negative 2 times, oops, my board's skipping. Negative 5 plus 3 times 0. Does that equal positive 10? Yeah, negative 2 times negative 5 is positive 10. That also works. So we would say, yes, it is a solution to the system of equations. How many of you remember doing systems back in Algebra 1?
Yep.
Okay. You had Mr. Ryan, I know he spent at least 4 weeks on it. You had Mrs. Bear, or Mrs. Ennis, I'm sorry. I think she only spent like 3 weeks on it. She didn't spend as much time. But that's okay. So what you're going to do next is you're going to make 3 tiny graphs. You can do this in the white portion, you can do it on the pink portion. It doesn't matter, but you don't need 3 pink graphs, just 3 regular graphs. And we're going to try to figure out how many solutions a system of equations can have. A system means 2 lines, right? Look, I have 2 lines. Raise your hand to tell me how many solutions they could have. One possible answer. Cool, you jumped straight to that one. I'm going to go over here and put that one down.
Okay.
Okay, that is when you have one line on top of another line. I'm trying to put the blue on top of the black there. Okay? And I'm actually going to write out the words here, Dawn. Infinitely many solutions. No, you don't have to write it out every single time. But in your notes, I like you to actually write it out. Because a lot of people, I found that if I just say, oh, it's IMS, about a week down the line, they'll say to me, what does IMS stand for? So when you're doing your homework, if you get infinitely many solutions, you can write IMS. I'm okay with that. You wrote it down once, so you can look back if you forget what they stand for, right? Well, what do you know about the slopes of these 2 lines? Okay, I have the same slope. What else do they have in common? Same slope, and y-intercept. I'm just going to abbreviate that y-in. And when we're looking at equations, that's the quick way to know if I have IMS. Now, somebody other than Dom. What's my other option here for two parallel lines? Okay. And how many solutions do they have, Sammy? They have none. That's right. None. So I have the option of having no solution. What do they have in common? Same slope. But, what? Different y-intercept. This may actually come in handy when I start making you solve systems algebraically. Well, if I solve them both for y and I see they have the same slope, different y-intercept, I can go straight to no solution. Okay? What's my other option? I've got one other option. One solution. And that's where they cross the one. There's nothing special I want to write about this slope or y-intercept here. The only thing I know is they have different slopes. They could have the same y-intercept. They could have different y-intercepts. Does that make sense? Okay, let's do one graphing problem then together. So, here is my lovely problem. And I have two equations. Before I can graph it, what do I need to do? It's good. So I'd like you to take a minute, write the two equations down, solve them for y, and then check with your group that everybody agrees. Okay. How many of you got these two equations? Good. Just because that first equation has all those fractions in it, don't panic. What I'd like you to do right now, though, is to graph y equals negative x plus 3. That's the easy equation, right? Negative x plus 3. No tricks on it, nice and simple to graph. Now, if you take a look at mine, I put lots of points on mine. And I see some of you pulling out rulers and straight edges and things like that. That makes me very happy. Yes. Why do you think I put so many points on mine? I don't know where the other line's going to be. That's a good one. The other reason? Hopefully then I drew a straighter line. I've seen some homework. And I don't know if it was from you or if it was from somebody else. But I've seen people put like just 2 or 3 dots on, and then their line looks like this. Not a very straight line, right? So that helps me to make a much straighter line to see where the other one intersects with. Okay? I've seen the whole like roller coaster line. That's great. Okay, so let's graph the bottom one. Y equals 2/3 x minus 1/3. What do I do with that negative 1/3? I can't move. I can't go up 1/3. That first dot has to be where? Every single time. It has to be on this axis. It has to be. I can't put it over here, over here, over here, over here. It has to be on this axis. No. And the reason is I actually like fractions when graphing. When I'm solving, okay, yes. When I'm just graphing though, I like fractions. So negative 1/3 in? Sammy? Between 0 and negative 1? Yeah, perfect. Between 0 and negative 1. It has to be on that axis. That's where your first dot always has to be. Now, Jake, that's probably the hardest part about it because now I love this fraction. It just means go up 2/3. Now, Dominic, I get to move. So I'm going to go up 2. Now notice when I go up 1, I'm between 0 and 1. When I go up 2, I'm between 1 and 2. 1, 2. Now if you take a look up here, I only put 2 dots on. Can you tell where they're going to connect as 2 lines? Yeah? And you don't need to put more dots on. I'm kind of nice. You put a lot of dots this way to help you out just in case. But now I can see where they connect. Go ahead and connect them. Go ahead and connect. Mackenzie, where do my 2 lines meet? Perfect. 2, 1. Now, I don't believe Mackenzie. What do I have to do in order to prove she's right? Plug it in. Or the way I like to say, check. You always check in the original equation. So I'm going back up to the black equation. 2 times 2 minus 3 times 1 equals 1. What's 2 times 2? Minus 3? That works. Let's try the other one. 2 plus 1, does that equal 3? Okay. Then, I now believe Mackenzie. Mackenzie, you are right. You did it right. But until she shows me a check, I don't believe it. Now, I always want to see a check. I will not make you do a million of these, so I expect to see a check. Also, that way whenever Mackenzie comes up and hands me her quiz, she won't even have to ask me, hey, when will you have that graded? She'll just look at me and say, I already know my grade, thank you. And she can walk away from me, right? I'm money happy, yeah. You can check them all. Sound good? Okay. Go ahead and pull out a clean sheet of graph paper for your essential work. Monday, can you guys do me a favor on Monday? Can you guys do me a favor on Monday? Remind me, I want to show you how to do this in the calculator. Pick a problem and do it in the calculator Monday. Cool? All right. Skip. Essential work. Here it is.